Hey, I just wanted to talk about the edge detection that I've been working on. Just been playing around with some different techniques. Uh, so basically, I'll just jump into it. And it only does this when I'm recording for whatever reason. I don't know why. Usually it remembers the place of the windows. But anyways, so what you have here is we got a test image, old winner, and what you're seeing here in the food map window is just this is a raw edge detector output. So this is what happens when you do the process of edge detection where you convol the image with a kernel to get it to gradient, and that's what you see here. And so typically what happens at this point is in traditional methods they will apply a threshold, which is what we're doing over here. Now this is a two-ended threshold, which just means that like I can it's whatever's between these two sliders. So if I go down here, if I really just want to see the noise, I can just look at the noise, or if I want to see, so basically, but it's just thresholding the pixels between those intensities. And if you play with these sliders, and if you've played with the different kernels and methods and stuff like I have, I mean, you realize there's only so much you can do. I mean, as far as, getting what you want as far as output. So basically what I've been working on is going a little bit further, and what I'm doing is I'm taking this, and the Canny method is a little bit better than this because this is just a strict threshold, but it takes this this thresholded image, and it uses it kind of like a mask to spawn what I'll be calling cell nodes, and I'll just do that now. So it may be a little bit difficult to see, but I got it pulled up over here. So this is what I mean. So basically, where that mask has white pixels, it will try to spawn a cell node there. And so this is one by itself. This is a single cell node. It's a 9 by 9 entity, with the main cell being in the center and the red part being what I'm calling its territory. Because some of the things that these things can do is they can basically eat from this food map. So they can eat the intensities. Basically, they'd be chomping away at the edges, and they can die. And they can't. I haven't got to the point where I can grow the chains yet, but I just got it all working, so that'll be coming real soon. So basically, it uses that threshold mask, and it will spawn nodes if the packing condition is met, and that's why you don't see two white squares right next to each other. It just goes down through that thresholded image, and then it at each pixel it checks all around it, and if the packing conditions are met, it'll spawn a node there. So they're not packed too tightly. This also reduces the total number of nodes that you have to iterate through. And the output of this would be you would just take all of the cell nodes and their territories, and you would just color them all white. So basically that would be the output. But right now what you're seeing is nothing's happening because right, because, well, nothing's happening. What I can show you is this. So the nodes are, it's kind of like they live in like there's like a hybridized data structure that they all live in. So there's a master list of nodes, which is just like a straight list of pointers, and then because the nodes are dynamically allocated, and then you have a sparse matrix, which is like the whole image, and it's just a sparse matrix of pointers where most of them are null, but some of them point to these nodes, and I use that to hook the chains together when I'm searching through it as an image space. And then the third and final and most important structure is I have a list of vectors, which are these chains. So I have a list of chains. So if we go up here, we see that we generated 2,000 cells and 190 chains. The longest chain being 249 cells. What you can do is the list of chains it is sorted by the length of the chain. So if you keep only the top 10 chains, then you're keeping the 10 longest chains. So how many chains did we start with? Like 100? We can take it down to like 20. And but that's just an interesting pruning method that I wasn't really thinking about when I started to make this. But what I really want to do is make these chains grow, and it would happen by these cells procreating. So let me show you how that works. So what I'm going to be doing is I'm going to be pressing a button which iterates through this, and call it a feeding cycle. And I forget what I have it set at, but I believe it only goes for like 8 or 10 iterations. Let me press that button. So you see that this is a health map, and it's just kind of a visual debugging thing. Like the green represents how much food is left in that node's territory combined. And then I think blue is the net energy that it's consumed, or the net energy that it has, because it also burns energy every iteration, and it consumes energy every iteration. And it's consuming energy from this image space. So as I iterate through there, you'll see those edges get eaten. And you'll also see this green convert from green to blue, and then the blue fades out as all the food's been eaten, So you'll see these edges right here kind of go away. So we had 0 cell births, 40, 419, 514, 529, 530. Now these births aren't happening. I'm just summing up how many would be happening so that I can get some of these constants reasonable. And so now all the food in all the territories is gone after 8 iterations. And so you'll see that all the cells die off. And what I want to have happen is say, find a good example. See, I already pruned it. Hold on a minute. So for instance, on this hat, you'll see where it was eating through the intensities where they were spawned. But say if this chain has like 12 births along it, what I'm going to do is I'm going to, the births happen along a chain. So it'll traverse up and down the chain with some kind of kernel. And basically it'll create this it'll create a list of potential birth spots, you call it, and that'll be sorted. And basically, those new births will be placed along this chain in the best spot where there's the most food. So you see that it stopped right there, but hopefully what would happen is that as new cells would be born, they would grow all along that until they, and if it meets this chain, it'll combine with that chain. So the idea is, yeah, these fucking things will just grow. And it took me a long time to get just everything kind of situated to where I know that my algorithms are working, and now I can move on to the actual birthing process. But I also wasn't really expecting this pruning thing to work so well. So I mean, and they kind of work against each other. So I'll give you an example of that. So this image is a picture of the course, the CV course, or the AutoNav course, and I've added a bunch of alpha to the lanes, so they're not nearly as opaque and bright as they were before. But that's what you're seeing coming through here. So what I was saying with these two methods kind of, or the pruning method and then this growing chains method kind of fight each other, and I'm trying to decide which one would be best to pursue. So for instance, right now we're kind of noisy, right? So the image is fairly noisy. We'll generate the nodes, and then we can keep 10. I mean, we made 2,961 cells and 853 individual chains, and we're going to only keep 10. So that works fairly well for suppressing noise. So I was kind of happy with that, but then, like what I was saying is, if I was going to use the other method where, I kind of use this as like a seed map and then grow from there, well, you don't want to start at the noisy end and then filter down. What you want to do is start on the super conservative side. So in that case, you'd want to start with something like that. Let me reset that. You'd start from something like this, and then you would grow the chains out that way. I'm not quite sure which method to pursue. I do like the fact that going this way and growing up, you only have like 350 cells, 150 chains. Get 150 chains. Let's keep a third of those. See what it looks like. Those are pretty good. So I mean, The other method, you have, literally thousands of nodes, and then you have to sort a list of thousands of, I mean, and it might not make much of a difference at all because I haven't even written the everything. I mean, I've got everything else working. I mean, I just haven't, you know, fucking deliver babies. I haven't wrote that shit yet. So, I don't know. Just let me know what you'll think. Should I start like that and then filter down, or should I start something like this and then like grow? I guess I'm gonna have to try them both and see which one works best. But yeah, if you have any ideas, let me know. Appreciate you for watching.